Okay, now we are going to solve practice problem 7.7 of Sadiku book. So the question is refer to figure 7.39, and this is the figure. Express IT. So IT is this curve here in terms of singularity functions. Okay, now we have a diagonal line. So we need to express this as two different kind of function. The first one is we have the unit step function ut, and remember that ut is like this. So we have when x is less than 0, the value of ut is 0, and when it's greater than 0, the value is 1. This is the value of ut. And then we have one more, which is the ramp function or rt, and this is defined as t multiplied by ut. Okay, and I will sketch it. So a ramp function is like this. So when t is less than 0, the value is 0 here. But when it's greater than 0, it will follow t. So it's like this. So this is rt. Okay, now let's check this function out. Okay, first, before 0, we don't know, but we just assume that it will be 0. And then at t is equal to 0, so now here the value of it is 2. Okay, so now we have it is equal to 2, and we want to multiply it by ut. Okay, so this is our first step, and I will sketch this. Okay, so now if we sketch this function into Cartesian coordinates, we will get this like this. So I will have 2ut is a horizontal line with the amplitude of 2. Okay, now a horizontal line has a gradient of 0. Okay, so now we want to change the gradient. Okay, so if we want to change the amplitude, we subtract or add with unit step, but we want to change gradient, so we want to subtract or add a ramp function. So now we have gradient 0, and we want to change it into this one. So how to calculate gradient? So we take a look at this line here, and we count the height here, the height. So this is 2 and this is minus 2, so the height is 4, and then the width of this is 2. So I will have this one is 4, so this one is 4, and this one is 2. So I will have 4 divided by 2, and then the sign, because it's diagonally going down, so the sign will be negative. So I will have the gradient here is minus 2. So we want to change the gradient from 0 into minus 2. So I will want to change the gradient, so I subtract this with a ramp function with amplitude of 2. So minus 2 rt. Okay, now let's sketch this function. So this function will change the gradient of this line. So I will have this line is from here to here. So we connect this line. And it goes all the way to infinity. But we want to change the gradient again at t is equal to 2. So now we have the gradient here is minus 2, but we want to change this again into this line. So I will have this one, the height of this triangle is 2, and then the width is 1. So I will have the gradient of this part. It will be 2 divided by 1. So I will have this one will be 2, and because it's going up, the sign will be positive. So I will need to change the gradient from -2 into 2. So I need to add 4 into this equation. So I will need this to be 4, and it is RT, and the offset will be 2. So I will have t minus 2. Okay, so I will sketch this function here. So I will have 3 here. Okay, I will have 3 here. Okay, maybe I should put this 3 here. And now at time t is equal to 3, we want the gradient to be changed again into 0. So now I have 2, the gradient will be 2, and I want to change it into 0. So similarly, I need to subtract -2. I need to subtract 2 from this function. So I will have -2, and that will be r, and the time offset is 3. So I will have t minus 3. So this is IT in terms of singularity functions, and this is the answer of this problem. So hopefully I did not make any mistakes in my calculation, and thank you for watching. Bye bye.